Hello friends, welcome back in the series Gen AI for .NET developers. In last sessions, we understand what is Gen AI architecture for enterprise applications, where we discuss about different layers and how you can build the layers when you develop Gen AI applications, because you already have experience what does means by layering system, layering architecture, what exactly it exists on the ground. So you although know these all terms very well. I don't think I need to explain you those the basic terms. But last session was about Gen AI applications architecture, and now the important topic in between this picture is large language model, because somehow we are used in our Gen AI applications, we use large language model. So what are the precautions, what things you should take care when you use or when you utilize LLM based systems? This session you will refer throughout the journey. It's not from the beginning, but I would say when you start building your industry level application with the help of Gen AI, you must refer this video. So I request please save this video, because these topics you will need time to time. You will have a demand, then you can refer this. So let's recap it, what you although know till now, and what exactly large language model. So as we know, large language model are advanced AI system. It's built on top of deep neural network, designed to process, understand, and generate human-like text, images, videos, audio that can create, right? But that was about the LLM. But now the question is, how do you control it? So the question is, at by the end of this session, you will understand engineering control layer with LLM. So if you design your large language model, you design Gen AI system with enablement of LLMs, but how you can make the better controlling, how you can make the governance in your application. You know, from the previous sessions and this history, LLM is probabilistic engine that generate content. Enterprise AI is orchestrated system. That means we have an umbrella of enterprise AI system, and where we use these layers, and one of the layer is called your large language model, where the model exactly exists. That's a brief about the high level about how a large language model actually looks like. So you can input through video, voice, text, images, and then large language model answer, questioning, answering, sentiment analysis, image captioning, understanding of image, extraction data from image, and object recognition. These all are the high level area of large language models. And large language models are primarily based on the transformers. We understand transformer, and I discuss in the detail about transformers in a deep learning sessions. But let's recap this. So LLMs are primarily based on the transformer architecture, which enables them to learn large range of dependencies. And how transformers exactly work: so as a user, when you import, then embedding and positional encoding will take place, and then encoder and decoder will start taking a place, which is called self-attention model. And then finally you have an output. So I'm not going to explain you the detail about transformer architecture here. I would my idea is just to have you the brief understanding at a very high level how transformers exactly works in the LLM. But now the question is, let's say you use the bigger LLM is really big by nature, yeah. So you use the LLM in your Gen AI application, but the control is you should control it, because LLM don't know about you, about your systems, about your behavior, about your privacy, yeah. So you need to control it. That's why it's called engineering controlling layer. So now I'm explaining very important and core area of LLMs. When you start using LLMs, how you can control it, how you can create your own controlling layer, how you can perform the governance monitoring for LLM based applications, means your Gen AI application. Let's start one by one. That's very important, guys, and you should take it very seriously, because that's not easy. It's not fashionated. You have to take care, otherwise you may face some challenges, and those challenges can come at a production. Probably you heard that most of Gen AI applications are failed on the productions. What was the reason? I wrote some articles, bigger articles on the LinkedIn as well. If you're interested, please refer my LinkedIn articles, and you will find it on the, yeah, on my articles. Now let's start talking about prompt control. This is called behavioral layer, behavioral control. Okay, I know you are new, and it is some there are in every video I come up with a new words, and you may trigger to search and then research more on those words, but no need to worry about it. Prompt is what exactly? The prompt is the input which you are providing. Think as in a chat GPT. So you have a chat GPT and you wanted to search something. That's not a kind of Google. You write a plain text and you search it. So it's little different. It's match your context. So you write some information, then the LLM, because in the chat GPT model behind it, that's understand your prompt, user query, or I can say user uh, instructions prompt, and then give you the result based on the best understanding. So prompt is an input. We need to understand like that. Prompt is a kind of input. Why this prompt control is required? Because if I can correlate your concept in the term, I think everyone, you will catch quickly. Everyone know about SQL injection. What does exactly mean by SQL injection? Because you are taking input from UI and then you are passing this to your SQL layer, and you want to ensure that nothing should be happen wrong, or nothing, no bad information. I will proceed with my database. Exactly, this is this, you need to, you can understand in the similar. So for just for your imagination, that is somehow just similar. Prompt controlling. So LLM don't know about your systems. You should tell, and you should control about your input and your output, because the way you inform to LLM using the prompt, it will generate the output accordingly. And we should ensure that no wrong information, or we should ensure about the data privacy or the words what exactly you are searching in the LLM. First is system instructions, means there are several kinds of instructions: system prompt, user prompt. We will definitely discuss more when we talk about prompt engineering, but at this the higher level, let's try to understand what this mean by those. Yeah. Okay. So system understanding. So this is basically system level guidelines you will provide. So the guidelines, and those guidelines will for what? Those guidelines for what you are requiring from LLM, and when your output would be generated or the LLM will process your input, then what are the guidelines LLM should follow. So these are system instructions, or called system prompt. I hope it's clear to you. Next concept is called Next concept is role separations. You need to separate the role. This is RBC controlling, role based access permissions. Uh, who can access, yeah, who can access what kind of data, and temperatures. The temperature is a new term. Role separation, I think it's not new for you. You understand better what does means by role label permissions, but temperature is something new. You may realize it when you continue your conversation over the chat GPT or Google Gemini, you can see sometimes it's based on your data, you enter the prompt and then very accurate information coming, sometimes it's not coming, but that's a standard protocol. Here the temperature is how accurately LLM will understand your input, your prompt, and generate the output format constraints. So I'm not going very deep, guys, so don't be confused. I'm not going very deep about the prompt engineering, because for prompt engineering I will clarify your each and every doubt, and I will explain all the concepts of the prompt engineering. But here our agenda is, while you are designing your Gen AI application, what things you should take care about prompt controlling. So output format constants, let's say you will tell the LLM, hey, I want my output in this format. Let's say if you are restrict and you raise it, you say no, I need whatever output generated by LLM, I need in JSON format, and you can define the JSON structure inside the system instruction. Then the LLM will generate output based on your system instructions, and you will have a JSON format output. I will also show you this in the practical sessions when we perform the practical session. And another thing is context compositions, process for reducing long conversation histories. You should control on those things. But the question is, so this is called your behavioral layer. But the question is, why everything is matters? Why you need? So this is matters because it's reduce randomness. LLM don't know about it. As you provide instructions, hey, you need to follow this route, it will start to following that route, your guidelines, your instructions, and generate output based on your information, whatever you're given inside the system instructions. And it improve determinism definitely, because now it's as per your business, and it mitigates prompt injection. So you follow these, you definitely mitigate the prompt injections. Wrong prompt will not happen. Let's say it is a really important, because if in a prompt, if someone input some sensitive keywords, or someone wants some financial information, and if you build a chatbot and someone it's connected to your DBs or the applications, and then if somebody want a financial information, that definitely you cannot share. Yeah, it's based on your data privacy. So what the privacy level allow as your organization, you can do that. So prompt engineering is very important. This is just like, how do you maintain your SQL? Yeah, how do you prepare your DVs? How do you control? Because this is the communication from your application to LLM. This is the communication in between. That's the prompt. So prompt control is plays a vital role when we talk about engineering control layers, or the layers in our Gen AI application. Next part is, that's again important, is called tool control. Let's say execution boundaries. For example, you are a travel company, and you built a Gen AI system, and you use LLM. You built your Gen AI system, and you built this a chatbot, and you want that my customer will fetch their information, their travel itineraries, their travel packages, or their information. The system will fetch it. But this cannot be possible just by the LLM, because LLM don't know about your company. LLM don't know who is your customer. So you must proceed in organized way. Yeah. So here you need to attach tools. Whenever a customer wanted to know about their travel journey, travel information, that tool should be used by LLM to fetch the information or fetch the data from your third party applications. So tools are required. And parameter validation, definitely you should validate about the parameters. That's exactly same we talked earlier. The input data, you have to validate it. And permission scoping, that's pretty important. What things can be accessed by which level? This is called obviously role based permission. Why it is matters, you need to understand. If because without tooling, LLM don't know about your systems. If you want, if you ask, hey, use, when user ask about the travel information or the packages, or user logged in my system, you need to share this info. So that system should know, the LLM should know what shall I call when user ask, hey, can you tell me my travel date. So where LLM will search, you need to, it should call the tooling. So tools would be called. Going forward, we will have practical sessions. We will definitely develop applications with the help of MCP, model context protocol, how we integrate our tools inside GenAI application. Why it matters, let's come back to the topic. Because it's prevent tool misuse. If you perform validations, it it restricts the attack surface, enforce safe automations. So your automation would be safer, and this prepare them for, we will use, that's very I mentioned this especially because we will use going forward for our GNI application development. We will use semantic kernel, that where we call functions calling and plugin attachment. Yeah, functions and plugin in your semantic kernel layer, which communicate to LLM, but with the root, following the root with the tooling and plugins. So the LLM will utilize that. Next, but important, output validation. That's called reliability layer. So you now, till then, you know about, you have a control over system instructions, prompt engineering you have performed, you perform tools or you attach the tools, this layer you prepare tools, plugins layer. But now this thing is output validation. When output is generated by LLM, then how do you validate that? So in the output validation, it's also called reliability layer, but those names are not fixed, guys. It's definitely based on your industry, your company, and how do you call that. But these things will not change. These things will never gonna change. Throughout the GenAI application journey, you always have those layers. You need to maintain those layers, because that is the, for the controlling how we use the power of large language models and how we can develop the industry ready applications. Output validations. So what you control, JSON schema enforcement. Let's say you want my output should be in the JSON. Response validation, you perform the validation in the response. This is called healing. This response validation is called healing. We will understand. I develop certain applications and develop own healers which heal, which just ensure the correctness. The healer you need to design that will ensure the response validation. And then filtering or validation rules, this is the part when you have response validation, then you have several rules. Business rules verification, definitely business rules verification must be performed. The data which is generated by LLM, because you cannot directly process the LLM generated output to the user. You have to pass through the LLM output in your several layers. Those layers called response validations, validations rules, business rules you need to perform. Why those output validation is required? Definitely privacy, your data, user information. It prevent hallucinated structured data, false output avoided being generated by the LLM, because this can be better control and precisely control when you perform output validation layer, that is called reliability layer. Protects further processing or connected systems. If something went wrong, then you can stop, hey, stop it, because your rules failed, and then you will not pass through with that for the systems or for the connected system. Another important things you should take care while you use LLMs in your system: observability, intelligence layer. This is I would say more about performance tracking, more about ML ops areas, not dedicatedly for developers. Some parts for developers, was majority part for ML ops candidate. But here I will, my mission is to train you completely on AI ready or Gen AI infrastructure or Gen AI ecosystem where you build your applications or build applications for industry. So what you monitor actually, so just this is just like a monitoring. Let's say you develop application and you perform you created a dashboard and you perform your application performance, you monitor the data logs, you monitor the user loads. These all you generally monitor when you develop your applications. But in the Gen AI application, what you will monitor, you will monitor the uses of token. What's you, because it's a cost, every request is a cost. So uses of token latency, the latency will comes in the picture. Let's say you deployed your model on the Azure infrastructure and then reason was different and your user base in the different users, so what latency actually there in between this. So you need to monitor this. Prompt versions, definitely you may have several version prompt versioning you can have. This will, and then failure patterns. So where it's failed, where LLM request failed, not able to generate output, what input drift uh, you trigger, you find in the LLM's output. This you need to do. Why it matters, because if you control the token uses, you know the latency, if there is any gap, you know the failure patterns, so you can correct those patterns. That will definitely cost optimization, continuous improvement. This is called continuous improvements, or you can say CI. And yeah, and debugging AI workflows. So if your workflows are failed in between somewhere, you got to know. If once you have a dashboard or you have a logging system, then you can track where exactly it's failed. So monitoring is very important. This is the governance. You need to follow it, and you must need it, because industry, you can't live with this. You have to have governance of your LLM. Yeah, whatever LLM you use, so you must have the governance. Then next is logging and monitoring. This is the part of this is the same layer. The one above is intelligence layer, what you monitor, and one is this logging and governance. So it's actually I divided in two, but you can club into, just try to club into one, logging and monitoring governance layer. So what do you know till now? You monitor how is performance of LLM requests. Is there any delays happen? What's the uses of token? What's failure patterns? You recognize it. Then who called the model? Input payload, output payload. That once you have a log, it's you error cases. What was the input and output when error comes? Yeah, that is useful for you. For these most of things, for the governance, monitoring, and the intelligence layer, we have interesting platform as a service. It's called PaaS, Azure AI Foundry, as a governance and deployment layer where we can control completeness of our Gen AI application. I know, guys, many words I explain new for you, and some of out of 5 feet or 4 feet you had, but no worries, you can watch this video several times, because throughout your journey in Gen AI development, Gen AI application development, you need these layers. These layers are the backbone of your Gen AI system. So it's, don't take it lightly. This is the very important. Initially I thought I will record this session in the mid or at last, but I think you can start, if we start building the right progress from the day one, that would be the solid framework, solid back, the it's called solid foundation. If your foundation is solid, then you will avoid to make mistakes in future. So thank you very much for watching this session, generative AI with the .NET. All .NET developers, you don't need to change your language, or you don't need to change the technology. Don't be in the market news that you need to learn the Python. I think that's not a blocker completely. If you want to explore new libraries, then you are most welcome to learn and explore the Python. But to sustain with the .NET ecosystem itself, you can build the industry ready Gen AI application, and then you can boost your career with the multi-folded layers. You can, this promise you need to do by yourself. If you continue this by several months, for 5 months, I think you can change your life, guys. Thank you very much for watching this video. If you really like my sessions, please join, subscribe, and share with your friends, so they can also boost their knowledge and they can enhance their knowledge in the era of .NET ecosystem. Stay with your platform. I think this is the pain for almost all .NET developers. Let's say if someone asks you to learn the new technology, then you are completely new with that. But here you have backbone, you have a strong basis which you protect, or which you grown up since many years. Then no need to switch it. This is my promise to everyone .NET developers. Stay tuned with the channel. On weekly basis, I'm trying to record sessions for you. Thank you very much. Thank you again for watching my session. In the next session, it's that would be practical, that would not be theoretical. In next session, we will understand how to create Azure account and how deploy our first model in Azure Foundry. Thank you very much. See you in next session. Goodbye.